section 6.7. And if you'll give me 1 second, I will leave it. I'll let it go. And what we're talking about is quadratic equations and problem solving. So if we were to look at the notes we did from 6.6, this is really the information we had from 6.6, and we looked at quadratic equations, and there were some important steps. Just remember, because we're going to be working with these today. The first thing we needed to do is we had to write the equation in the form of ax squared plus bx plus c equals 0. So the equation had to be equal to 0. Sometimes we had to do some multiplication and adding and subtracting of terms over the equal sign to get there. But we had to get the equation equal to 0. Then we factored the quadratic expression that is on one side. Okay, after that, we used we applied the zero product property, which is to set each factor equal to 0 and then solve. And from that, we got our solutions. So we're going to move on to 6.7 today, and we're going to use quadratic equations to solve word problems. Right? The applications, that's why we have them, right? Is that, we have math to solve problems, or we have math to give us information. Really important. And then information goes back to healthcare services, right? Sciences with pharmacy and engineering and math and education and art. There's even math and art. So let's go ahead and just jump into this first example. And one thing students are always wondering about formulas. And for the most part, I will give a lot of formulas on the test, but once the review is done and the test is written, we can talk more about formulas on the day of review. So with 6.7, we have one. Okay, so from Bree, go ahead and look at Bree's. She sent it to everybody. Thank you, Bree, about finding your grades on my math lab. Appreciate it. So example 1, it says, so stained glass. The length of, I'm moving this over, there we go. The length of the base of a standard glass window is 3 times its height. Okay, and the area is 96 square feet. Find the length of its base and its height. All right, so one thing that we definitely want to look for, right, is we need to find the length and the height. Okay, the first question you should be able to ask before you even look at approaching a word problem or writing an equation is we need to know what we're looking for. So I did notice that our length, if we look at the diagram, our length is equal to 3h. It's given to you in the diagram. We also could have figured it out from the wording, right? Because it says the length of the base is 3 times its height, right? But the diagram pictures are there to help us as well, and its height is equal to h. So it gives us a little bit more information, and it talks about its area. Okay, its area. Now with the area of a triangle, the area equals 1/2 the base times the height. Now with the base, we could call that the length as well. So if I were to look at this picture, this would be the base. Okay, is the 3h. So this is base and the length are the same. So what I'm going to do, I have the formula and I have length and height expressed with the same variable. So I'm going to put the information in that I have. All right, with area, okay, here's my formula once again. Area is equal to 1/2 the base times the height. Area is equal, I'm actually even going to back up a little bit. I know what my area is. My area is 96 square feet. Wonderful. So 96, that's my area, is equal to 1/2 times the base, which is 3h, times the height, which is 8. So the only thing that I did is I replaced each of the variables with what it was equal to, with the information from the question. Now I'm going to simplify. When I simplify this, and I'm going to move it up just a little bit here, because I'm getting back to my algebra, is I'm going to write, okay, 96 is equal to, the 3 will go above the 2, and then I have h squared. Okay, that's what I have. Okay, great. 96 is equal to 3 halves h squared. Now, one thing that I would want to do is I want to get rid of that fraction. Okay, I really want to get rid of that fraction. And you could do it two different ways. What I'm going to do, just for simple measures here, is I'm going to multiply both sides by a 2, and 2 times 196 is 192, or sorry, times 96 is 192. The 2's cancel on the right, and I get 3h squared. Okay. The next thing I'm going to do is I'm going to subtract 192 from both sides. Now, why am I doing that? I have to solve this equation. And to do that, I have to get my ax squared plus bx plus c equal to 0. All right, so I'm going to subtract 192 from both sides, and I have 3h squared minus 192. All right, I'm going to move this up, make a little bit of room, and I'm going to move this up here for more room. All right, so 0 is equal to 3h squared minus 192. All right, now my next step, once I get the equation equal to 0, is I need to factor. In this case, it's the right-hand side. Now, part of factoring, we take out a greatest common factor. Now, that's 3. 3 is a factor of 3, and 3 is a factor of 192. So when I take out that greatest common factor, I have 3 times h squared minus 64. And you can go ahead and check my math, but I know it's h squared minus 64. And at that point, once I take the greatest common factor out, I'm going to factor what's left inside the parentheses. All right, I'm going to factor. I'm going to take that 3 along. This is a difference of 2 squares. Difference of 2 squares. That was in the special form section. And I know since it's a difference of 2 squares, I'm going to have an h, and h squared. What squared gives you h squared? It's h. I'm going to have a plus and a minus. And then what squared gives you 64? It would be 8 and 8. Now, what we're going to do next is we use the zero product property. I have it fully factored. It's equal to 0 and it's fully factored. And now we're going to set each of the factors, I see 3 of them, equal to 0 to solve. So, my first factor is a 3, but does it make sense to say 3 is equal to 0? No, that's nonsense. We're just going to cancel it out. Okay, we don't need to look at that factor anymore. So if a factor doesn't have a variable in it, we can just disregard it. Now let's look at the other 2 factors. We have h plus 8 is equal to 0, which means h is equal to a negative 8. Okay, or we have h minus 8 is equal to 0, which means h is equal to a positive 8. Great. We have solved for h. Now, in the chat, let's take a look in the chat. Does it make sense, or what are your thoughts on h equaling a negative 8? Does it make sense that the height of a triangle is negative 8? I would say no. It doesn't make sense. So this doesn't make sense at all. You don't have negative length of sides. So we know that h is equal to 8. So we can say for our answer, the height, which was -8, or 8, is 8 feet. And the length, which is 3 times, it is 3 times the height. 3 times 8 is 24 feet. 8 feet and 24 feet. Okay. And this would be our answer. So let's go ahead and box it in. So setting up the equation is a big part. And then after that, we're going to use factoring to solve. Let's look at the next example. An object is dropped from the roof of a 144-foot tall building. Neglecting air resistance, the height, which is h in feet, of the object above ground after t seconds is given by the equation h equals -16t squared plus 144. Find how long it takes the object to hit the ground. All right, well, we need to figure out what we're looking for, right? The equation, and let's just go ahead and highlight this, is h equals -16t squared plus 144. Now, what is the height going to be? Because I need to get this example represented by one equation, or one variable, right? This equation and one variable before I can use factoring to solve. So I'm just going to draw a little diagram. So it's a 144-foot building. So I'm going to go ahead and draw this, right? And here's my 144-foot building. Okay, so 144 feet tall. I have an object, we'll say it's a water balloon. Okay, here's my water balloon that I'm going to drop. So it starts at 144 feet. And then it hits the ground, right? So when since it hits the ground, it's going to go big splat, right? Big splat when it hits the ground. What is the height of the water balloon when it hits the ground? Well, it starts at 144 feet and it goes all the way down to 0 feet. So the height here is going to be equal to 0. So we'll put that in. So if we replace 0 with an h, it's equal to 16t squared plus 144. All right, so our equation, once we replace the height with 0, which is the height when the water balloon hits the ground, and then we need, so our equation is already equal to 0. It has that t squared. So the first thing that I'm going to do, because I have to factor the right-hand side of this equation, is I'm going to factor out a -16, because that is a common factor. How did I know that? Well, I know that, first of all, I have to take the negative out with it because the first term is negative. But 16, once I do a little checking, does go into 144 evenly. So I would actually write -16 times t squared minus, it goes in there 9 times. 9 times. So with that, I continue with my factoring, and I need to factor what is left. So I have t minus 3, write that a little bit neater, and t plus 3. I will use the zero product property. I'm going to set each factor equal to 0. Okay, that first factor negative 16 equals 0. It doesn't make sense. It didn't have a variable, so I wouldn't have had to do that, but I just like to show that it doesn't make sense. If t is equal to, or t minus 3 equals 0, then t is equal to a 3. And the third one, or if t plus 3 is equal to 0, then t is equal to a negative 3. Now with word problems, because we have two answers here, 3 and negative 3. And we have to make sure our answer makes sense. Now what we're looking for here is how long it takes the object to hit the ground. Now, does it make sense for it to be a negative 3 seconds? Because that would actually mean that it hit the ground 3 seconds before I dropped it, right? So that doesn't make sense. That would be called an extraneous, it's just an extra answer, but it doesn't have any use. But does it make sense that if you drop a water balloon from the top of a building, or any object from the top of a building, that it takes 3 seconds to hit the ground? And that would be, yeah, it does. So our answer is t equal to 3, or it took 3 seconds to hit the ground. And that would be our answer. To make sure, a difference that we have between answering questions on MyMathLab and answering the questions on a test is it's easy to not, or to forget to label our answers for a test. All right, so 3 seconds. Any questions? All right, let's take a look at the next example. The product of two consecutive odd numbers is 63. Find the numbers. Okay, well, you've seen these before, but we did them a little differently, right? We weren't using quadratics, but we worked with these consecutive numbers before. We were adding them previously. So when I look at two consecutive odd numbers, excuse me, I dropped my pen. We would be looking at numbers like 7 and 9, or 211 and 213. So the first thing is I'm going to have two numbers. So I'm going to have my first number. We're going to let just be x. It can be any, pick your favorite variable, right? But we're going to say it's just x. And then we have to have a second number. So the second number has to be consecutive odd. So we have to say remain odd. So to go from like 7 to 9, I would add 2, right? To go from 211 to 213, I would add 2. So if I start with an x, my next consecutive number will be x plus 2. Now they give us a little more information. They tell us that it's a product and that it is 63. Okay, is, right? That's where that equal sign goes. So this means that if I have x, the first number, times, because it's a product, x plus 2, I end up with, it is 63. So what we have is a quadratic equation. And now I have to find the numbers. Well, to find these numbers, the first thing I have to do is to get this equation in the form of x squared, or ax squared plus bx plus c equal to 0. So I have to remove the parentheses. And I would do that through distributing that x through. And then I'm going to subtract 63 from both sides. And what that'll do is it helps me get the 0 on one side. Okay, so that was the first thing we need to do. We are ready to factor the left-hand side. Okay, we have to bring that 0 along. So here's my my answer area, right? Since the lead coefficient right here, it's a plane x squared, it's equal to 1. Because that's true, I know there's an x in the first place of each of the binomials. How am I going to factor it? Well, when I factor this type of trinomial, I look for the factors of negative 63, so a factor pair that adds up to a 2. So that's my focus. The factor pair of negative 63 that adds up to a 2. Now we've done those charts before and they're great. Okay, here's my negative 63 and a 2. And if I think about it, my factor pair would be 9 and negative 7. Now you can write out all the factor pairs. We did that in section 6.2 and we worked on that again in 6.5, I think. But these are going to be my factors. And since that lead coefficient's a 1, I can put these factors in here. Now it does change when the lead coefficient isn't a 1, okay? But this would be my factored trinomial. But I'm not done because I need a solution. So what I would do next is I set each of the factors, x plus 9 equals 0, or x minus 7 equals 0. And then I solve them. Okay, well, x plus 9 equals 0, then x has to be a negative 9. Or if x minus 7 equals 0, then x has to be a positive 7. So I have two options. Now look at this. It says the product of consecutive odd numbers is 63. Find the numbers. I have two solutions, and that's fine because it doesn't specify if the numbers are negative or positive. So if I have x equal to negative 9, my next number would be x plus 2 or a negative 7. I'm going to write that a little bit neater. Let me get those signs in a little bit better here. Is it true that negative 9 times negative 7 is 63? Yes, it is. Now, if x is equal to a positive 7, then x plus 2 is equal to a 9. I would add 2 to 7, I get 9. Is it true that 7 times 9 is 63? And the answer is yes. So we have two sets of solutions. That's perfect. So what we'll say, how we should communicate this is the numbers are negative 9 and negative 7, or 7 and 9, because they satisfy our question. They're consecutive odd numbers that multiply to 63. And this would be our solution. And it's okay to have two sets of numbers as long as they make sense. They make sense. And what I mean is the previous example, negative 3 didn't make sense for time. We don't say it's negative 3 seconds. Okay, but for this example, when we were just talking about numbers, consecutive odd numbers, negative 9 and 7 is a logical solution, and 7 and 9, another good, solid, logical solution. Any questions? Okay, well, let's take a look at the Pythagorean theorem. All right, I love the Pythagorean theorem. Love, maybe that's a little bit strong, but it's a wonderful theorem, okay? And when we have it, a couple of things, we'll just read it through and I'll pick out a couple of important information. Pythagorean theorem, in a right triangle, the sum of the squares of the lengths of the two legs is equal to the square of the length of the hypotenuse. And it gives you the formula, the leg A squared plus leg B squared is equal to hypotenuse squared. And we have our triangle. Now, with this example, this is our right angle. And the right angle is a 90-degree angle. And it is denoted by that little box in the corner. When you see that little box, that means it's a right angle. Now, how we more familiar, I guess it's more familiar to state it this way, is if I have a right angle, we have A, we have B, and we have C, and we always label the hypotenuse being the longest side of a right triangle. We always label that with a C. The other two we can interchange, the A and the B we can interchange, but the C has to be the hypotenuse. And if this is the case, Pythagorean theorem is A squared plus B squared is equal to C squared. Pythagorean theorem. So we can use this. This is actually used often when we're using triangles. But let's go ahead and use it in an example. So I want us to find the length of a hypotenuse of a triangle, of a right triangle, if the lengths of the legs are 3 feet and 4 feet. So with triangles, I recommend write a picture, draw a picture. So with that, here's my triangle. And this is the hypotenuse, okay, C. This is my right angle. Now, again, it says find the length of the hypotenuse of a right triangle if the length of the legs are, now the legs are the two shorter sides. So we have 3 feet and we have 4 feet. Okay. So with this, when I hear a right triangle, find the hypotenuse, I think Pythagorean theorem. So I'm going to go ahead and write, here's my A squared plus B squared is equal to C squared. I will have 3 squared plus 4 squared equals C squared. Okay, so I replaced A with what I knew A was, B with what B was. And again, you can interchange those two sides, that's fine. And it's equal to C squared. So now I need to solve. And I can solve that. Let's just continue to combine like terms. So I have 9 plus 16 is equal to C squared, or 25 is equal to C squared. All right, now we can, actually probably figure this out and say what squared gives me 25. We can probably do that. Or we can use our factoring, either way. So let's go ahead and subtract, just so we have practice here. Let's go ahead and subtract the 25 from both sides. All right, I'm going to bring it up here. And I know that 0 is equal to C plus 5 times C minus 5 because it is the difference of two squares, which means either C plus 5 equals 0 or C minus 5 equals 0. All right, solving both of these. If C plus 5 equals 0, then C is a negative 5. That doesn't make sense because it's length, it's feet. All right, so we don't have negative feet. So I go to the next one. If C minus 5 equals 0, then C is equal to a positive 5. Now that makes sense. All right, so the hypotenuse, and I'm just going to abbreviate it, is 5 feet. And that would be my solution. All right, so it's an example of using the Pythagorean theorem to solve a word problem. All right, let's go on to the next example. And 2 more left. Let's do one more and then we'll take a break. All right. If the length of one leg of a right triangle is 4 meters and the length of the hypotenuse is 13 meters, find the length of the other leg. All right. So it's a triangle, and I'm going to use a diagram to help me figure this out. I'm just going to label it, and then I'll think about what I'm going to do. So one leg of the triangle is 4 meters. All right, so I'm just going to put 4 meters on one of the legs. And the length of the hypotenuse, right here, is 13 meters. All right, so the hypotenuse, which is the longest side of a right triangle, it's also the side of the triangle that is opposite the right angle, okay, is 13 meters. Find the other leg. Okay, well, the other leg I'm going to say is my A. It could be B. You know, legs are interchangeable, but we'll just say it's A. And I know I'm going to use the Pythagorean theorem because that is the equation that gives that relationship, okay, between all the sides of a right triangle. So I'm going to put what I know in. So A squared plus 4 squared, because that's one of my legs, is equal to 13 squared, my hypotenuse squared. So A squared plus 16 is equal to 13 squared, 169. All right, I'm going to see 4 squared. I think I have everything right. I think it looks good. All right, so if I were to subtract 169 from both sides, I have A squared, and then 16 minus 169 is a minus 153 is equal to 0. Well, I don't have the difference of 2 squares, do I? I don't. So what are we going to do? What are we going to do? Well, what I recommend with this, since we can't factor, I'm going to actually add the 153 from both sides. I think there was a typo in my notes, actually. And that's fine. And then what we'll go ahead and we'll just, we can do two things. We can approximate using our calculator, or we can go ahead and approximate what this would be by just estimation. Now, what I know is that 12 squared is 144, and I know that 13 squared is 169. So that means that our A, has to be between these two. So I'm just going to go ahead and I'm going to say also that it's probably a little closer to 144. So A, we're going to say is approximately 12.5. Okay, just a little estimation, and we'll put meters. Sorry about that. I think the answer, when I look at this, I think it was supposed to be 5 meters, but there must have been a typo in my notes. 5 meters would have made it perfect. All right, we have one more example. And with that, we'll begin right after break. So let's say 5 minutes. We'll begin again on my clock, it'd be, well, just 5 minutes from now, take a look at your clock, okay? We'll see you in a little bit.